So if I have 9, right? Now 9 is actually the same as 3 squared, right? So these are kind of properties of exponents. So 9 is the same as 3 squared, right? So I want to show you some stuff, okay? The square root of 9 is equal to plus or minus 3, right? But the square root of 9 is really 3 squared, which is still equal to plus or minus 3, okay? Now, if I say the square root of 16, that's plus or minus 4, but really 16 is the same as 4 squared. So that equals, now there should be a pattern you should start to recognize. The base, when I take the square root of anything squared, the base is the solution. That's what you're left with. Now what that comes from is that when you take the square root of a number, so same problem, square root of 9, that's the same as saying 9 raised to the 1 over 2. We don't write it down, but this is 9 to the first power raised to the 1/2. This would be the numerator of the fraction, and this would be the denominator. Now when we take square roots, we're really taking the second root, right? But we never write the 2 down because it's so common. So that's the same as 3 squared raised to the 1/2. Now if you remember your properties of exponents, what do I do with these two numbers here? To simplify that. Nope, don't add. When you raise a power to a power, what do we do? Multiply. So what's 2 times 1/2, or what's 1/2 of 2? 3 to the first power. Does that make sense? Now let's do this again. If I say the square root of 16, what I'm really saying is 16 raised to the 1 over 2, right? Which is really the same as 4 squared raised to the 1/2. When you multiply 1/2 times 2, what do you get? 4 to the first, which is 4. And we got to tack on the plus or minus, right? Does that make sense to you guys so far? Now, if I say the square root of x plus 3 squared, I'm really saying x plus 3 squared raised to the 1/2. Well, what's 1/2 of 2? 1. So this is actually equal to x plus 3. So we're just left with the base. So when you do the square root of a square, you're just left with the base, because the square root is kind of the inverse operation of squaring something. It's like saying 3 times 4 is 12, but 12 divided by 4 is 3, right? You're kind of undoing what you've done. So when you take the square root of a square, they cancel each other out, mathematically speaking, and you're left with the base. Does that make sense?